Here's the solution key for assignment 31. We're asked to find these derivatives. Notice we're taking the derivative of an integral that involves a variable in the upper bound in most of the cases. So we're using our fundamental theorem of calculus, which states that we're going to replace the variable in the integrand with the variable in the upper bound. So a lot of these problems are going to go pretty quick. Problem number 1, we just see an x here, so we replace t with x, and that's the short version of getting our derivative. So x squared minus the square root of x. Problem number 2, same process, 1 over x squared plus 4. Problem number 3, doesn't matter that the low bound is negative 1. Doesn't matter what the number the low bound is at all. We just replace the x in for the u. So we have the square root of x squared minus 1. Problem number 4, we see that the bounds are in the wrong spot. We want the x in the upper bound, so we're going to swap them. And the cost of swapping them is that we have to negate our integral. So we're going to end up having the opposite of the square root of 3x plus 1. For problem number 5, now we have an inner function, x squared. So we replace t with x squared, like so, but then we have to multiply by the derivative of the inner function because we're taking a derivative. There's an inner function, which means we must use the chain rule. So we have to multiply this entire thing by the derivative of x squared, which is 2x. So this answer is fine here, but keep in mind also that this could be simplified to 2x times x to the 4th plus 1. Same situation. T is going to be replaced by 2x plus 1, so we're going to have sine of the quantity 2x plus 1, but we have to multiply by the derivative of 2x plus 1, which is 2. So we need 2 sine 2x plus 1. With number 7, we have to swap the bounds again, so we need the 4x squared up here and the 2 down there, which means that our integral will be negative. So we replace t with 4x squared. So we have 1 over the quantity 1 plus the quantity 4x squared cubed. And we need to multiply that by the derivative of the inner function. The inner function is 4x squared. Its derivative is 8x. So there's our answer. And if we simplify this just a touch, the 8x can move into the numerator. And then we have 1 plus, and keep in mind that both the 4 and the x squared are being cubed. 4 cubed is 4 times 4 times 4, or 64. And x squared cubed means that we multiply the exponents, so we have x to the 6th. Both answers are correct. And then over here, u is being replaced by the square root of x, so we have tangent of the square root of x, and that needs to be multiplied by the derivative of the square root of x. So keep in mind that x under the radical is the same thing as x to the 1/2, so we have 1/2 x to the negative 1/2. That answer is great. If you have that answer, you're fine. Again, if you're looking to simplify, a negative exponent becomes positive if it's moved down into the denominator, like so. The 2 is already down in the denominator. Tangent of root x is up in the numerator, and because it has a positive exponent. And then something to the 1/2 power we know is to the square root. So this is the same thing as saying the tangent of the square root of x over 2 times the square root of x. Either answer is fine.